we're going to review order of operations and equivalent expressions. And so first I just want to talk about equivalent expressions. All that means are expressions which have an equal value. So for a simple example, we could talk about the fraction 5/2. So 5/2 is equivalent to 5 divided by 2, which is equivalent to 2.5. which is the same as 2 plus 1/2. And we could keep going on and on and on. And all of these, even though they look different, are equivalent expressions because they all hold the same value. If you compute any of these, you'll get 2.5 or 5/2. And they're all the same, or at least hold the same value, even if they don't look the same. Now suppose we want to write this expression as a simplified fraction. So basically we want to combine everything, simplify the expression, and we know we don't want it as a decimal, we want it as a simplified fraction. So we've got to go through and do quite a few operations here, and you guys may have heard the acronym PEMDAS, which kind of gives you an outline for what operations to perform first. So the P stands for parentheses, so you work within the parentheses first. The E is exponents. M and D are multiplication and division. And A and D are addition and subtraction. So we're going to kind of simplify this expression using that kind of rule book. So we've got 1/2 times, we have a set of parentheses, so we're going to work within there first. We have 3/4 minus 1/4, so we're left with 2/4, which I could leave as 2/4, but I could also notice that I can simplify that. And I will tell you that usually it's pretty nice to simplify as you go. So I'm going to replace the 2/4 with a 1/2. Okay, now we have 1/2 times 1/2 squared. So we can go ahead and do that. We have 1/2 times, to deal with this exponent on a fraction, I'm going to go ahead and square both the numerator and the denominator. So I get 1 squared over 2 squared. Well, 1 squared just gives me 1, and 2 squared gives me 4. And now I have 1/2 times 1/4 plus 3/8. When I do the multiplication, I get 1 times 1 is 1, 2 times 4 is 8, and then I'm adding 3/8, which I have a common denominator, so I can go ahead and add them. 1/8 and 3/8 is going to give me 4/8. And I want to simplify this fraction, so I can divide out by 4 on both the numerator and denominator and get 1/2. So this original expression looks all ugly, but it reduces down and holds the same value as 1/2. All right, now we're going to simplify this expression and write it as an integer. So we're going to use PEMDAS again. So I'll go ahead and start on what's within my parentheses. I've got this 2 minus 5 gives me a -3. And I can actually work over here on this 24 divided by 8 right now because I know that I'll do the division before the subtraction. So the 24 divided by 8 and the 2 minus 5 squared are kind of independent of each other. So I've got 24 divided by 8 gives me a 3. Now, before I do the subtraction, I've got to work on the exponent. So I have 3 minus -3 squared is the same as -3 times the -3, which gives me a +9. So I have 3 minus +9. And now when I do that subtraction, I have 3 minus positive 9 gives me a negative 6, which is a single integer. All right, now we're going to write the decimal equivalent of 3/4 minus 1/2. We have two options here. I can either go straight into converting to decimals. I know that 3/4 is actually 0.75, and 1/2 is actually 0.5. And when I subtract these two, I end up getting 0.25. which would be the decimal equivalent. Right, now we're going to write the decimal equivalent of 7/9, and suppose we don't have a calculator. So a lot of you guys probably knew that 1/4 is going to come out to 0.25 because we're kind of used to dealing with money. A quarter of a dollar, literally called a quarter, is 25 cents. But we might not know 7/9 off the top of our head. So what we can do instead, if we don't have a calculator, is do long division. So I have 7 divided by 9. And I'm going to ask myself, does 9 go into 7? And it does not. So I add a decimal point and a 0. And I ask myself, does 9 go into 70? And it does. 7 times. And that gives me 63. So 9 goes into 77 times, and I've got 63. When I subtract 70 minus 63, I get 7. Well, then I ask myself the same thing. Does 9 go into 7? And it does not, so I add another 0. And then you might notice that we're starting to repeat. Now I'm asking, does 9 go into 70? And we're like, yes, it does. It goes in 7 times. And 9 times 7 is 63. And when I subtract, I get 7. And then you're like, wait a second. I'm repeating the same thing again. I'll add another 0. I'll get 70. I'll say it goes in 7 times. And then I'll get 63. And then I subtract, and we get 7. And we're like, it never ends. And that's okay, because this decimal doesn't actually ever end. It's a repeating decimal. But once we notice the pattern that we're going to continue repeating with the 7, we can say, all right, 7 divided by 9 is none other than 0.7 repeating. All right, we've got one more problem. For this one, I would suggest pausing the video, trying to see if you can do it on your own. I think it's a good kind of thought problem. So if you want to pause the video, go ahead and do that now. Okay, so we have that we're building a box out of a 5.5 by 3/4 foot sheet of plywood. Suppose we want a square base, open top, and to use all of the wood. And what dimensions could your box be? So let's kind of think about what we're working with. We're trying to build this box, right? So we have this box that we're trying to build. Doing my best to draw this box. And we know that we want it to have a square base. And we know that we're working with a piece of plywood that is 3/4 foot by 5.5 feet. So we've got this whole side is 5.5 feet. So if we think about cutting this piece of wood, we have a bunch of different options. There's not a unique answer to this problem. But maybe if we want a square base, what if we choose the base to be 3/4 foot by 3/4 foot? So basically, I cut off this much for my base. So my base will become this 3/4 by 3/4. then that lets me kind of divide up this next section into the walls of my box. And I don't have to worry about having a top. So once I have my base, I'm like, okay, I can divide the rest up into my 4 sides. So basically this. So I'm going to have a side here, side here, side here, side here, and then my bottom is right here. So this is my bottom, and then my sides. So if I want to figure out the dimensions for my box, I know that the base is going to be 3/4 by 3/4. I just need to figure out what the height of my box is going to be. So that's this height right here, which is going to be these heights. So what I need to do is figure out how much am I left from this 5.5 length piece of plywood when I cut off the 3/4 chunk. So I'm gonna take 5.5. I'm gonna cut off the 3/4 piece. And then I'm gonna cut that up into 4 equal pieces. So I'm gonna divide this by 4. Equivalently, we can multiply it by 1/4. So now we've got this problem to solve. And I'm going to try to find an equivalent expression to this and simplify this down so then I have a nice, fraction that I can use. So I work within the parentheses first. I've got 1/4 times, I've got 5.5, which is, intuitive. You know that it's 5 feet and plus 1/2 foot. But it's a little bit hard to do our operations with. So I'm going to convert this into an improper fraction. So to do that, I'm going to put it all over halves. So I've got 5 plus 1/2, which is like 10 halves plus 1/2, or 11 halves. So I've got this. And to subtract these fractions, I've got to make sure that I've got a common denominator. So I'm going to rewrite 11 halves in terms of how many quarters those are. And 11 halves would be the same as 22 quarters. So now I can do this subtraction. So I've got 1/4 times 22 minus 3 gives me 19 over 4. And then when I do this multiplication, I get 19 over 16. And so those are going to be my heights. That's this is going to be 19 sixteenths. 19 sixteenths of a foot. 19 sixteenths. 19 sixteenths. And that guarantees that I'm going to use up all of my wood. So then, for the, summing up this problem, our dimensions should be, or could be, 3/4 foot by 3/4 foot by 19 sixteenths foot for our box.